Hi, this is Mrs. Valletta. I thought I'd make a screencast for you so you know how to graph a data set and you could refer back to it when you're struggling and can't remember what to do. So I've taken a data set from a cart running down a track, and I've done 4 time trials at half a meter, 1 meter, 1.5 meters, and 2 meters. And I've taken the average of my times at each position and I've written it here in my data table. I've got one last one to do. So we've got the 2.1, 2.09, 2.18, and 2.15, and we want to know the average. So I put those in the calculator. I sum them up. Let's make sure we sum them up. So 2.11 plus 2.09 plus 2.18 plus 2.15. We take the sum of that and we divide by our number of trials, which is 4, and we get our average for the data. And so that would be 2.13. That's a lot of decimals, and our timers only have 2 decimals, so we're only allowed 3 decimals in our data set. So I'm going to round that last position from a 2 to a 3 and round it up. So 2.133 seconds. Okay, so now we have our data set and we're ready to graph. I'd like you to please pause the video right now and pull out page number 8 from your binder. That's the 6 easy steps for graphing. And so I'll take a minute. Please pull that out. In the meantime, I'm going to move this out of the way and find a new piece of graph paper. All right, so you found your steps? Great. All right, so I want to remind you that physicists are measuring motion of objects over time, and so they always put their time variable, the independent variable, on the x-axis. And our unit of time is seconds, so I'm going to label that. Because remember, rule number 1 is label our axes. And we measured the motion of our cart on the ramps, and even though the ramps are in centimeters, you need to convert your data, that's the distance that it traveled, into meters. And if you can't remember how to do that, you can find a little tutorial on it on the back side of page number 5, the history of the metric system. So do refer to that. Okay, so I think that I followed step number 1, and we're ready for step number 2, and that's the most difficult step of all of them. So step number 2 says you look at your data, and we'll start with the x-axis, which is time, and you find the maximum, that's the biggest value, and we put a box around it. So my biggest average time is 2.33 seconds. And we need to figure out how much each box on this axis is worth by taking the maximum time and dividing by the number of boxes. And if you remember from class, there are 14 boxes on the x-axis. So let's figure out our scale on the x-axis. That's 2.133 seconds divided by 14 boxes, because we'd like to know how many seconds to make each box work. So there's 2.133 divided by 14 boxes, and I get a number that's a little bit hard to count by. And I'm going to round up to 0.2. I'm going to make every time box worth 0.2 because I can count by that number, right? So it's approximately 0.2. And I'll label my x-axis. So every box is 0.2 starting at 0, so that's 0.2. I'm not going to label every box. It makes the graph a little bit messy. It's hard to read. 1.2, 1.6, 1.8, but I'm not going to stop until I get all the way to the end. Okay, so I think I've done my x-axis, and now let's do it again for the y-axis. So this is my distance, and I go back to my data set, and I find my maximum distance. Well, what is my maximum distance? It's 2 meters. All right, so rule number 2 says take your maximum value. That's 2 meters. And you want to divide by the number of boxes, and I'll just remind you from class that that was 14 boxes. So 2 meters divided by 14 boxes, and let's try to figure out the scale on the y-axis. So 2 divided by 14, That's 0.14. If I was feeling ambitious and strong, I would do every box worth 0.15. If you're not feeling as confident, you're probably going to do, and remember this is 0.2 is our scale. Okay. That doesn't work for every data set. That just works for my data set. You might want to pause the video and try to figure out your scales and label your axis. And I'll go ahead and do ours. Okay, so 0.2, 0.4. Again, I'm not going to label every box. 0.4, 0.6, 0.8, 1, 1.2, 0.4, 1.6, 1.8, 2.0, 2.2, 2.4, 2.6, 2.8. Okay, and so now I finished rule number 2. Now my data should all fit nicely on the graph and cover 2/3 of the graph. That's why we do rule number 2. We want to see the data spread out so that it looks nice. And so rule number 3, well, rule number 3 is the fun one. It's where we get to graph our data points, our X and Y coordinate points. And so our first point, of course, is the cart started at the top of the ramp at 0 time and 0 seconds. That was our reference point. And the very first data that we took was at 0.87 seconds. So this is 0.8, that's 1, so somewhere around here. It had gone half a meter. And I'm going to put a point there. Remember, you're going to have to estimate when you don't fall directly on the grid. Our next data point is 1.5 seconds. And we're going to go up here at 1.5 seconds. We had gone 1 meter. All right, so that's about right there. At 1.875 seconds, 1.875 seconds, we had gone 1.5 meters. All right, so that's 0.4, so that's about it. And our last data point is 2.33 seconds, 2.13 seconds, excuse me. So that's there, and we've gone a full 2 meters. Now our data is on our graph. All right, so we're ready for rule number 4, where we should describe what it is that we're graphing. And what I graphed was the average time for a cart rolling down a ramp. All right. And then I'm going to draw my curve in here. And it's a best fit curve. Not all the points are going to come on the curve, but that's my best fit curve. Some points are above and some points are below, but that's okay. That's rule number 5. And our last rule is rule number 6, that we need to put in a color-coded legend. And all I have right now is my buggy. And so I'll put, oh, excuse me, it's my cart. What am I doing? It's my cart. And now I have a graph that displays my data, and when we look at it, we can easily tell that it's a curve and the cart was accelerating, that it was going faster and faster. Now, if we wanted to take the slope of part of this, I'm going to pick a point of the graph where it's pretty straight. If I want to know the velocity of the car between those 2 points, then I'm going to make a slope triangle. Okay, so let me come over here and make a slope triangle. Try to do this right here. So there's my slope triangle between those 2 points. And you're like, but Mrs. Valletta, it's not on the grid. No, that's true. But because this is a curve, I'm just going to use this as an estimate for right now. This is a pretty straight section, so I'm going to have to estimate. And I need to know how much distance it traveled. And to do that, I actually have to read the values. So if I want to know this change in distance, remember that's the rise of the graph, I'm going to go over here and I'm going to read the distance. That's 1 meter at the top. And I'm going to read the bottom. And so this is about, remember, this would be about 0.5. So 1 meter minus 0.5 meters. And it's an estimation, especially when you're doing a curve. When you do your tumble buggy, you'll be able to get a precise slope. So that's my change in height. That's my rise on the graph. And this is what's called my run of the graph. That's how far time changed. And so I'm going to come down here and read time. That looks like that's about 0.85, give or take, 0.85 seconds. And this looks like this is about 1.35 seconds. And now I can figure out the slope, which will be my velocity, meters per second, of that portion of the curve. And again, we're just practicing slopes, you guys. So 1 minus 0.5 will give us 0.5 meters. And we're going to divide, the bottom is 1.35 seconds minus 0.85 seconds. That gives us 0.5 seconds. And of course, we can't leave it as a ratio. So 0.5 divided by 0.5, well, that's 1 meter per second. So that's how fast my cart was traveling this portion of the graph. Now, you know it's traveling slower because it's shallow than steep, and even a little bit steeper. Okay. All right, well, that's all for now. I hope that helped you remember the 6 easy steps to graphing and practice taking a slope on the curve in order to get the velocity. For those of you who are feeling very, very advanced, you can come in. A more precise value would be to take a tangent line and take the slope of the tangent line like we did in class. And that would give us a more precise slope. So, should take. All right, well, I hope that helps. If you have questions, do please email me. Again, slopes on curve are the advanced features. Slope on straight lines is what's being required in class. Thanks, and I'll see you in class. Bye now.